everyone, how is everyone doing? In this video, I'm going to touch on how to model a power bar switch as the switch pivot point break due to usage. Most power bar get hot when loaded. The heat could cause the switch pivot point to weaken and break over time, which is what I found in this particular power bar. When the switch pivot point is broken, it means you cannot switch it on or off, which makes it unsafe to use. Instead of throwing the power bar away and create some environmental trash, I'm going to model out the broken switch with FreeCAD software, print it with 3D printer and get it replaced. Alright, let's get started with the 3D modeling of the switch. Start your FreeCAD. If you do not have a copy of FreeCAD, go to freecadweb.org. You can download the installer for Windows, Mac and Linux. In your FreeCAD, select Part Design Workbench. Create a new document by going to File, New, or click on the New Document tools here. Next, create a new body, then a new sketch. Use the XY plane. In the sketcher, we're going to create the switch by first of all using a line tools and draw a horizontal line here, followed by another horizontal line on top here. The distance of the top longer horizontal line will be 20.9 mm. The shorter horizontal line distance is 16.3. To make the shorter horizontal line symmetric to the y-axis and constrained to the origin, select the line, then select axis origin followed by the symmetric tools. Same go with the longer horizontal line. Select both endpoints of the line followed by the y-axis, then click on the symmetric tool to make the horizontal line symmetric across the y-axis. Next, the distance between here to the origin vertical height is 6.5 mm. Alright, next we're going to draw two arcs on both sides here. Use the endpoint and rim point arc tools. Connect from the top to the bottom here and put the arc there. Alright, from this point to here, the distance is 1.11 mm. Alright, next we're going to draw the next arc on this side. Okay, next we'll make both arcs the same by selecting this arc and this arc and use the equal tools. Now you can see the sketch is fully constrained. Close it and we're going to pair up to 24.6. Alright, so this is how the switch main body look like. Next, we're going to select this surface here and create a thickness using the thickness tool to create a thickness of 1.2 mm and make the thickness inward. Alright, so that you keep to the original size that we have. Alright, click OK. The next one is to create two cylinders inside here, which is the pivoting leg for the switches. Alright, click on this surface. Start a new sketch. Let's draw two circles here that's aligned to the y-axis. 1, 2, and another two circles up here. 1, 2. The inner circle radius is 1.95 mm and the outer radius circle will be 2.75 mm, and we'll make this inner circle and the top inner circle same by using the equal tools. Likewise, go to the outer circle to the top outer circle here, equal them. Alright, and then the distance from here to the origin and the vertical distance will be 4.85 mm. And from the origin here to the top circle here, the vertical distance is 19.75 mm. Alright, as you can see, that is fully constrained. Close the sketch, and now we pad it up to 10.6 mm. Alright, we are good with that. The next thing is to create a two small pivot point. Let's select this surface. Let's centralize the sketch. So here we're going to create a circle here by using the circle tools and make sure they align to the axis. Alright, the radius for this one will be 1.3 mm. Alright, we want this one to be aligned here to the center half of this, and we know that the distance from this point to this point, the vertical distance is 6.5. Alright, you can see the sketch is fully constrained. Close it. Now let's create a pad for this, and we will need to have two dimensions, right? Okay, the first dimension here is 1.9, and the second dimension is 1.2 mm. Alright, next let's draw the other pivot point on this side here. Select the side, create a new sketch. Alright, likewise, going to draw a circle here, align to the axis. Okay, the radius again is 1.3 mm, and the distance from here to here is 6.5 mm. Alright, again we are fully constrained. Close the sketch, and next thing again we pad it up, and the distance is 1.9. Again we need to have both sides so that you can hold it tight there, right? So the other dimension will be 1.2, which is the thickness of the switch itself. So this is how it look like. With that, we are done with the switches, and we can save it. Alright, we will save it as switch 1. Alright, and then we will export this switch out to STL format. Let's export it, and we'll call it switch and save it. With the 3D model done and exported to STL format, we are now ready to import the STL into the 3D printer slicer software. Click add the STL file to the slicer. This is how it looks like on the slicers. We're going to print the switch with PLA filament. As for the infill, we will keep it as what array have it here, 50%. In fact, it does not really matter whether is it 100%, 30% or 50%, because the switch thickness itself is very thin. So even when you print with 50% or 30%, you will still print it in 100%. Alright, if you are happy with how it looks like on the slicer, what you need to do is to slice it. Click on slide now, and it will show you how the switch been or the model been sliced. And you can drag the layer bar here and look at each layer how it look like in slice format. Of course, you can rotate it to look at it on the various angles. By the way, if you notice here, there are some green color support structure being printed because this is created for the protruding part here, which is the pivot point. And for this one to be printed, the support here, I previously selected support on build plate only. So this is something you need to select if you have not selected that in order to get this support structure here. You can also scroll down the right panel here to look at the amount of time you will take to print is 19 minutes, and the amount of filament consumed by this printing is about 0.6 meter. When everything is good, what you just need to do is click on Export G-code button here, and you can use the default name given, or you can type in your own name and then click on Save button. When it's exported, it will pop out a message here to tell you that the G-code file is exported successfully. With that, now you can copy over to your 3D printer and get the model printed. With the 3D model printed, let's get the broken switch in the power bar replaced. Once again, if you are fixing any malfunction power bar, please be sure to unplug the power plug from the power socket and only disassemble the power bar if you are trained. Take the printed switch, place it into the holding bracket, align the bracket onto the power bar, take one screw and tighten one side of the bracket. Then tighten the other screw. Test the switch is working by seesawing it between on and off position. Everything works. Now you can put on the top cover. With the power bar fully assembled, connect to power socket and test it is working as expected. Let's recap what we have covered. I have this power bar with broken switch. We use FreeCAD part design workbench to model the part with pad and thickness tool with sketches created in the Sketcher workbench using geometry tools. We use constraint and dimension tool in the Sketcher workbench to ensure the sketch are designed to precision. Once the 3D model is completed, we export it to STL format that can be used on the 3D printer slicer software to slice it for 3D printing. Finally, with the printed part, we replace the broken switch in the power bar and test it is function properly. If you like this series of video and would like to support it, you can simply like the video, share it with your friends, family members, and colleagues who can benefit from learning how to design 3D models using a CAD software and print them for daily usage. Of course, remember to subscribe for future videos. Thanks for your attention. Bye.